Welcome to this Wiseowl Excel VBA tutorial. In this part of our series on writing SQL for Excel files, we're going to cover date expressions. We'll begin with some basic examples of formatting dates, and then show you a range of different functions you can use to extract parts of dates. We'll then do the reverse and construct dates from separate parts, and then move on to look at how you can use date expressions in the criteria of your queries. We'll explain how you can calculate the current date and time, how you can use that to calculate past and future dates, and for the final part of the video, how to calculate the difference between dates, including how to calculate the age in years accurately. So let's get started. If you've been following along with previous parts of this series, you'll be fairly familiar with the basic setup by now, so you may prefer just to skip to the next part of the video. If you haven't seen previous parts of the series, here's a quick look at the basic setup. We've got a basic macro-enabled workbook which allows us to run a query by clicking this fairly obviously labelled button. When we do that, it's going to extract some information from a separate Excel file called Movies. And the Movies workbook contains a list of films and of actors in different worksheets, and we'll be extracting data from each worksheet at different parts of the video. You're welcome to keep the Movies workbook open or close it down, all of the code will still work regardless. I've got both of these files stored in the same folder, and I'll drop a link in the video description so that you can download these files and follow along and write the code with me if you'd like to. The code in the Date Expressions workbook relies heavily on Microsoft ActiveX data objects. I'm not going to talk about that too much in this video, we've got a separate playlist which covers that. This series is meant to focus on the SQL side of things. If you are interested in the ActiveX data object side of things and how to establish connections to workbooks, etc., then I'd recommend starting with this video here, How Do I Get Data from a Closed Excel File Using VBA, in the Excel VBA Working with Databases playlist. And again, I'll drop a link in the video description so that you can find that one easily enough. Just to have a quick look at the basic code in the Date Expressions workbook. When we click the Run Query button, that triggers a subroutine called Create SQL Query. And the job of this subroutine is really just to construct the string which represents our select statement. So I've got a couple of basic ones, one that selects from the film table and one that selects from the actors table, which is currently commented out. When we constructed the string, we then pass that into a separate subroutine which deals with all the complicated stuff such as connecting to the Excel workbook using ActiveX data objects. It populates a record set using the results of our SQL query, so that's where our query text gets used to populate the source property of the record set. And then there's a bunch of extra code that writes out the information returned in the record set to a brand new Excel worksheet. To just have a very quick look at how that actually works, if we switch back to the menu sheet in the Date Expressions workbook, click the Run Query button, it extracts the title and the release date columns from the film worksheet in the Movies workbook. One of the simplest things we can do in terms of date expressions is apply some formatting to the dates in our queries. Now this workbook does already contain some code which applies formatting to any date columns in the record set. You may be able to see here if I select a cell containing a release date, it shows me that I've got a custom number format applied to that cell, and the formula bar shows you the standard short date format for that value. The code which does that is contained in the Get Query Results subroutine. If I just quickly scroll down to show you that section, there's an if statement here which checks if the data type of the column is a date data type, then it applies formatting to the cell containing those dates in the Excel worksheet. Now that's fine as long as you're writing your data out into a worksheet, but you won't necessarily always be doing that. So let's see how we can apply some formatting to the query columns rather than to the Excel worksheets after the data has been written out. I'll scroll back up to the top of this subroutine, and then I'm going to add a new column to our select list. It's going to involve the film release date, so rather than write out the entire thing from scratch, I'm going to copy that column and then just paste it in immediately below. I'm then going to use a function that allows us to format a date or a time. It's got a clever name, it's called FormatDateTime. And then if I open up some round brackets after that, I've got two arguments I need to fill in. First of all, the date or the time that we want to format, so that's the film's release date, followed by a comma, and then a number which indicates which particular date format to use. I'm going to enter the number 1 here, which corresponds to the standard system long date format. So I'm going to assign an alias to this column to say as FDT, short for Format Date Time, long date. And I'll wrap that up in some square brackets. The other date format you can apply using the FormatDateTime function. If I copy and paste that line of code, if I change the number of the format to the number 2, I can change that to a short date. So having done that, if I head back to my menu sheet, click the Run Query button again, you'll see that this time I've got the dates formatted, not using the VBA code in the separate getQueryResult subroutine, but using the FormatDateTime function in the query itself. Now there is something of a difference in terms of the output of our two new columns. If I compare this with the original release date column, if I just change the width of that to make it a bit easier to see, you can hopefully make out that the date values in that column are aligned to the right hand side of the cell. And if I selected one of these values, for example 03 May 2002, the formula bar shows me the standard short date format for that date. The two new columns have all their values aligned to the left hand side of the cell. And if I selected 03 May 2002, you can see that that's exactly what is shown in the formula bar. So Excel is treating these values as text. That's the data type of the output of the FormatDateTime function. Another good clue that these two columns aren't being treated as dates any longer is the code that we're using to format the cells after the data has been written into the Excel worksheet. If I scroll back down to find that if function again, or that if statement I should say, if the type of those columns was a date data type, then they would be reformatted to have this new date format, so the same one that is applied currently to the release date column. So the fact that those two new columns don't have this format is another clue that the data type of those columns is no longer date. That's not really something we need to do anything about. You can still write formulae in the Excel worksheet which treats these values as dates. So for example, if I used a basic Excel function to calculate the year from either of those two cells, it will happily calculate the year from that string of text. Because it can be treated as a date, Excel will happily do so. And if I do the exact same thing for this cell here, in fact, if I try to do the exact same thing for this cell here, it will also be treated as a date, even though technically it's stored as text. The FormatDateTime function is useful, but it is limited in terms of the number of date formats it can produce. If we want a little more flexibility in our date formats, we could use a different function instead. Let's head back to the Visual Basic Editor, and I'm going to scroll up to the top of the subroutine, top of the module I should say, and then I'm just going to copy one of my two FormatDateTime function lines. So I'll copy the FormatDateTime long date line, paste that in just below, and then I'm going to change the name of the function from FormatDateTime to just format. The two parameters I'm going to fill in here are the date that I want to apply my format to, and then the specific format that I would like to apply to that value. But rather than entering this as a number, we enter this as a string. So I'm going to open up some single quotes, and then actually just to begin with, I'm going to reproduce what we did with the FormatDateTime function. But I'm going to do this by typing in the name of the long date format. I can then close the single quotes, and I'll just change the name of this column, or the alias of this column, to say F long date. And then I'm just going to copy and paste that line again, and then change the name of the function, or sorry, the name of the format to short date, and do the same thing for the column alias. Having done that, if I head back to my menu sheet and I run that query again, you can see we've basically got exactly the same output from the format function as we did with the FormatDateTime function, and again the data type of the output of that function is treated as text. As well as using named date formats, you can also type in your own custom date formats using combinations of the letter D, M and Y. Just to demonstrate how that works, let's head back to the Visual Basic Editor, and I'm going to copy and paste the last line we put into our select list. And then I'm just going to change the alias of that column and call it custom date. Then I can take away the named date format, short date, and still inside the single quotes, start by typing in a single letter D. And that's a perfectly legitimate date format, and if I were to run my query at that point, it would format my date to show just the single digit day of the month. So imagine my film was released on today's date, the 5th of June 2021. The date format for that column would come out as the number 5. If I type in 2 Ds, that would come out as 05. If I type in 3 Ds, that would come out as the short name of the day of the week, so Sat. And then 4 Ds would come out as Saturday. If I then type in a space, I can type in a single D after that, so that will come out as Saturday 5. A single D will also handle dates from the 10th of the month as well, so if I type in a D and it was the 10th of the month, that would still come out as the number 10, not just a 1 or a 0. So 4 Ds followed by a space followed by a single D, and then another space. And it's the same principle for the months. If I type in a single letter M, that would come out as the number 6. 2 M's would be 06, 3 would be Jun, and 4 would be June. Another space, and then for years you want either 2 or 4 Ys. So YY would give you the year without the century, and 4 Ys would give you the year with the century. You can also use combinations of punctuation characters in here, so if you wanted to separate these different portions with hyphens or / characters, you can include those as well. I think this one works a little more neatly just using spaces rather than punctuation. Anyway, having done all that, let's head back to the menu sheet, run that query again, and we get our own fairly elaborate custom date format in the final column. Now let's move on to look at some functions which are designed to extract certain portions of a date. I'm just going to tidy up a little bit first. I'm going to go to my menu sheet and click the Delete All But Menu Sheet button to get rid of every sheet except for the menu sheet. And then back in the Visual Basic Editor, I'm going to get rid of a couple of these redundant columns. Let's get rid of the Format Date Time columns. They do just what the Format function does with the long date and short date named formats. For the next column, let's create a new line. So I'm going to insert a new line with some double quote characters, beginning with a comma, and then I'm going to use a function called year, open some round brackets, and then simply pass in the reference to the release date field. So you can probably guess what portion of the date that function is going to return. It is of course going to be the year. So I'm going to assign an alias to that column. I'll call this one release year. And there's a similarly simple function that you can use to extract the month and the day and the weekday. So let's concatenate a continuation character, and then rather than writing all that out again from scratch, let's just copy the year function, or the entire line involving the year function, and then change the year to say month in both the function name and the column alias. We'll paste it in again just below, and we'll extract the day. So this is the day of the month. Let's call this release day of month. And I'll spell month correctly eventually. And then finally, we'll have a function called weekday, release day of week. Okay, so 4 specific functions designed to extract a specific piece of a date. If we head back to the menu sheet and run that query, we'll find we get these 4 new columns, each showing us the correct portion from the original date. The 4 functions we've just used there all return their result as a number. But what if you wanted to return a piece of text instead? Let's say that instead of the month number, you wanted to return the name of the month. Now, probably the simplest way to do this is just to use the format function and apply a format using 4 M's, and that would just return the name of the month of the release date. But just to show you this one other function that we have available as well, if I head back to the Visual Basic Editor, I'm going to start by copying and pasting the line which calculates the month number, because we do actually need this for the next function to work. If I paste that in and then just change the alias to say release month name, and then at the beginning of that line, just after the comma, I'm going to type in the function month name, open up some round brackets, and then close an extra set of round brackets after the film release date. So the month name function accepts a number between 1 and 12, and then returns the name of the month from January to December. If I head back to the menu sheet and I run that query, you can hopefully see that we've got the full long month name shown in the next column. It's also possible to return the short month name, so the equivalent of using the format function and using 3 M's. To do that, I can specify a second argument of the MonthName function. So we have the month function nested in here as the first argument, type in a comma, and then say true, which indicates that you do want to abbreviate the names of the months. So if I head back to the menu sheet and I run that query again, we'll get the same information, just with abbreviated month names rather than the full ones. We can do a similar thing to get the name of the day of the week, although again it's much easier to do this using the format function and using either 3 or 4 Ds depending on whether you want the short or full day of the week name. But again, just to demonstrate how the WeekdayName function works, and one little potential problem with this, I'm going to copy and paste my release day of week column definition and then paste that in at the end of the select list. Release day of week name is the new name I'm going to give to that column. And then in the same pattern we used for the month name, I'm going to write weekday name in front of the weekday function, open up some round brackets, and then close an extra set of round brackets after the film's release date. Now at this point, if I head back to my menu sheet and I choose to run that query, you may notice a subtle difference in terms of the results. So with our custom date format, where we simply formatted that date to include the name of the day of the week, Jurassic Park was released on a Friday. If I head across to the new column we've just created, apparently now Jurassic Park was released on a Saturday. Now this is due to another setting in both the weekday and the weekday name functions actually, which allow you to specify which day is the first day of the week. If I have a quick look back at a help page for either the weekday function or the weekday name functions, each of these indicates they have a first day of week parameter, which you can set to be any day of the week, and the default is to have Sunday as the first day of the week. I'm going to change mine to say that Monday is the first day of the week by setting the day of week parameter to the number 2. So to do that, I'm going to head back to the Visual Basic Editor, and I'll do this inside the weekday function. So after I've specified f.releaseDate, I can type in a comma followed by the number 2. If I then head back to the menu sheet and I run that query again, I'll see this time I'm releasing Jurassic Park on a Friday, which is the correct day of the week. Just as with the month name function, it's possible to shorten or abbreviate the month name, you can abbreviate the weekday name as well. There's a separate parameter in the weekday name function which allows you to abbreviate the day name. So to do that, I'm going to head back to the Visual Basic Editor, and then after I've closed off the weekday function, so in between those two closed round brackets, I can set the abbreviate parameter to true. And one more time, if I head back to the menu sheet and run that query, I'll get the abbreviated day of the week name. At this point, I'm just going to tidy things up a little bit, so I'm going to go back to my menu sheet and choose to delete all but the menu sheet. Then I'm going to head back to the Visual Basic Editor, and I'm going to get rid of a couple of these extra columns. I'm going to get rid of my custom date and short date columns just to tidy up a little bit, and get rid of the extra blank line there as well. And I'm going to get rid of the weekday name column as well, just to give myself a little more space for the next little section. Now there may be other units of time that you're interested in calculating from your dates, such as the quarter, the week of the year, or the day of the year. While we don't have specific functions for calculating those intervals, there is a more generic function we can use to perform that task. It's called DatePart. And if I just refer quickly to the documentation for the DatePart function, you can see if I scroll down a little further to the settings section, these are the different units of time that we can calculate. So there's of course some duplication here, but it also gives us access to things like the quarter, the day of the year, and the week of the year. So just to quickly demonstrate how that works, let's head back to the Visual Basic Editor, and I'm going to create a new column using the DatePart function. So I'm going to add a new column from scratch this time. I'll type in some double quotes on the next line, followed by a comma, and then the DatePart function before opening up some round brackets. Now I'm going to start by specifying which unit or interval of time I'm interested in. So I'm going to say Q in some single quotes. followed by a comma, and then it's going to be the film's release date. So I'm just going to copy and paste that part to avoid having to type it out. And then I can close the round brackets and say as release quarter. If I could spell that correctly, there we go. I can then close the double quotes and concatenate a continuation character. And as before, rather than writing that out again, let's copy and paste it a couple of times. And then I'm going to change the units of time to WW for release week. And then finally, Y, a single Y, for day of the year. So release day of year. Okay, so having done that, if I head back to my menu sheet and run that query again, I get 3 new columns. So I think we've dealt fairly comprehensively with picking a data apart into its separate components. But what if we needed to do the opposite of that? What if, for example, you have your dates stored as a separate year, month and day, and you need to construct a complete date out of those separate units? Well, we have functions which allow us to do that as well. Let's head back to the Visual Basic Editor, and I'm just going to get rid of my DatePart columns again, just to tidy up a little bit to make my life a little easier for the next stage. And then on this new line, I'm going to open up some more double quotes, type in a comma, and then type in the function called DateSerial. Now the DateSerial function accepts a year as a number, a month as a number, and a day of the month as a number, and then constructs that into a complete date. Now, of course, we don't have those separate units of time stored in our movies database or our movies workbook. We've got only complete dates stored here. But we have calculated the separate components, a year, a month, and a day of the month. So we're just going to put all of those back together again, fairly pointlessly, I admit, but just to demonstrate the principle of the thing. Now, one of the nice things about using AdoDB is that you can reference previously created custom columns in subsequent columns in your select list. So I'm just going to basically list out the release year, the release month, and finally the release day of month aliases. I can then close the round brackets and then give this an alias. Let's call it date of release, just to distinguish it from our previous columns. And then we can concatenate a continuation character at the end. And having done that, we can head back to the menu sheet and run that query again. And we basically construct our release date column again. Hopefully you can see that this is definitely treated as a date. So you can see that unlike the format functions which left align the date value and treat it as text, the DateSerial function does construct an actual date value. So you can see it's right aligned in the cell. If I select the cell, it shows me the short date format, and it has the formatting applied according to the if function in the getQueryResults subroutine, or I should say if statement. So it's definitely recognizing that new column as a date data type and applying this number format appropriately. So you can use DateSerial when you have the year, month and day stored as numbers, but what if you have your date stored as text that you want to convert into a date? Well, there's another function for that called DateValue. Let's first of all just construct a string of text which looks like a date. So I'm just going to concatenate 3 of our previous columns together to look like a date in a new column. So let's add a new line to the select list, and I'm going to start by using the release day of month field. So I'm just going to copy and paste that. And then I'm going to concatenate that with a literal space character in some single quotes, and concatenate that with the month name or release month name. Now, of course, I could be copying and pasting the actual functions themselves, which calculate these parts, but it seems simpler here. We end up with a shorter column if we just reference the existing aliases. I'll concatenate another literal space character and then finally concatenate a release year as well. And then assign an alias to that column. Let's call this one as date of release 2, because I've run out of inventive names for my columns at this point. So date of release 2. I can then close the double quotes at the end and concatenate a continuation character. And then if we head back to the menu sheet and we run that query, we end up with a new column, which is again, this time clearly text. You can see that it's left aligned in the cell and it's showing you the 11 June 1993 text rather than the short date format. So now what I would like to do is take that piece of text and convert it into a date. And to do that, I can wrap the DateValue function around this expression. So I can say at the beginning of that line, after the comma, DateValue, open up some round brackets, and then close the round brackets just before my as keyword. So having done that, I can head back to the menu sheet, run the query again, and this time we should see that the same value is now right aligned in the cell, and selecting that value shows you the short date format in the formula bar. For the next part of the video, I'd like to move on to using these date expressions in the where clause of our query to affect which rows get returned. I'm just going to start by tidying things up a bit. From the menu sheet, I'll delete all but the menu sheet. And then heading back to the Visual Basic Editor, I'd like to move on to using the actor table rather than the film table. So I'm going to comment out the original SQL query. I can do that by typing a single apostrophe at the beginning of the SQL query line, and then reverse that for the actor query. So just to give this one a very quick test at this point, if I head back to my menu sheet and I run that query, I can see a list of all of the actors and their dates of births. Now I'd like to apply some criteria to show people who were born on a specific day. So let's use today's date as our original starting point. Let's use the 5th of June and then a specific year. I'm going to go for 1971. So just to remind you of how to write a date into a criteria in a query, if I head to the end of my from clause and then include a continuation character, and then add a where clause on the next line, and then I'm going to place the actual conditions on a separate line as well. So I'm going to concatenate another continuation character, and then I'm going to check where a.dob is equal to a specific date. Now, when you want to type a date value into a query in ADODB, you need to wrap it up in some hash symbols when we're using the provider to connect to an Excel workbook at least. So some hash marks to contain your date, and you have quite a lot of choice in what date format you can use. But I'd recommend sticking with something that's unambiguous. So for example, if I typed in 05/06/1971, would that be read as the 5th of June 1971 or May the 6th 1971? It's unclear. We've talked about this in a previous video on the where clause, so I prefer to be less ambiguous, shall we say. Write a date format in which the month cannot be misinterpreted. If I say 05 June or 05 June 1971, the word June must represent the month of the year. So having done that, I can then close the double quotes at the end and then head back to the menu sheet and run that query again, and I get the one single person born on that date in that year. Another date format you may see commonly used, if I head back to the Visual Basic Editor, I can add a second criterion to the same where clause. So I can say where a.dob is the 5th of June 1971 or a.dob equals, and then again in some hash marks I can use a standardized way of writing dates. I'm going to go for a separate year. I'm going to go with 1975-06-04. Now that date format conforms to an international standard, ISO 8601, which dictates you should write your dates following this sequence: year, followed by month, followed by day, and then if there was a time component involved, it will be hour, minute, second. So you gradually work from the larger portion of time to the smaller portion of time. So it's designed to be less ambiguous, shall we say. So having done that, if I head back to the menu sheet and run that query again, we'll see we get the combination of people born on either of those two different dates. So writing specific dates in a condition is fairly straightforward, but what if we want to do something a little more elaborate? Let's say we want to find any actor in the table born on the 1st of June in any year. To do that, we can calculate whether the actor's date of birth has a month of 6 and a day of 1. So to do that, let's head back to the Visual Basic Editor. And I'm going to change my condition by, first of all, wrapping the month function around the first reference to a.dob. We've already seen earlier on that the month function returns the number of the day of the month, so we can simply, the number of the month of the year, so I can simply check if that is equal to the number 6. Then I want to combine that condition, not using the OR operator, using the AND operator this time. And then I can wrap the day function around the second reference to the actor's date of birth and check if that is equal to the number 1. Okay, so having done that, I can head back to the menu sheet and I can run that query again. And that shows me all of the people born on the 1st of June in any year at all. I can do somewhat more elaborate things again. So any of the standard operators, the comparison operators we've encountered in earlier videos are acceptable here. You can calculate a portion of the date and then use that portion of the date in any condition you like. So let's say I want to find people born on either the 1st or the 2nd or the 7th of the June in any year for some bizarre reason. So to do that, I can head back to the Visual Basic Editor, and now I'm going to say day not equal to 1, but in a specific list of values. So after the word in, I can open up some round brackets and then 1, 2, 7, and then close the round brackets. I could then head back to the menu sheet and run that query again, and I'll find people born on either the 1st, 2nd or 7th of June in any year. You can also use date functions in the order by clause to change the sorting of your results. So let's say I wanted to sort these people based first of all on the day of the month and then by the year. So to do that, back in the Visual Basic Editor, we can add another clause to the end of our query. So I can concatenate another continuation character, and let's have the order by clause this time. I'll then put this on a separate line again to another continuation character. And I'll start by sorting in ascending order of day of the month. So I'm going to copy and paste the day a.dob and put that in ascending order, followed by a comma, and then I'm just going to paste in again day of a.dob, and then change the function to say year, and let's put that in descending order. So having done that, we can head back to the menu sheet and run that query again, and we get exactly what we've asked for. You'll probably find that a lot of your date-time comparisons involve working with the current date or the current time, and we have a couple of functions we can use to calculate those values. Just to show you those in a basic way first, if I head back to the Visual Basic Editor, I'd like to add a couple of columns to my select list, 3 columns in fact. One's going to calculate the current date. So I'm going to type in a new line starting with a double quote and a comma, and then I'm going to use a function called date. Now, the date function doesn't have any parameters, but because it's a function, it requires the open and closed round brackets. I'm going to give that an alias. I'm going to call that one as today, and then I'll concatenate a continuation character to the end of that. And then let's just copy and paste that. We can probably do this more quickly by copying and pasting than writing out the entire thing from scratch. And I'm going to change the function name from date to now. And I'm going to call that one I'll call it now. And then finally, I'm not sure you'll find much use for this one, but if I paste in once again that same line, I'm going to use a function called timer. Now the timer function returns the number of seconds since midnight. So let's call that one seconds since midnight. Okay, so not that this is particularly useful just to show those values in a column, but let's head back to the menu sheet and run that query again, and you should see that we get the same value on each row. Of course, because I've applied a date format, a specific custom format to the date and time columns, it's masking the time of day in the now column, but you can see if I click between today and now and look in the formula bar that the time has been included. If we did want to format that in a particular way, we could modify our code to include a time of day. And in fact, just to very quickly show you that, if I head down to the section of code which applies that format, let's add in an HH:MM:SS to get the hour, minute and second. So having done that, back to the menu sheet one more time, and run the query, and you can hopefully now clearly see that the today function basically has its time set to midnight on that day, whereas the now function includes the time of day at which the query was executed. I don't want to mess up all of my subsequent date formats for the rest of the video, so I'm just going to switch back to the Visual Basic Editor, and I'm going to take away the hour, minute and second part of the format, and then head back up and look at what useful things we can do now that we can calculate the current date. So one basic thing we could do is change our where clause to find anybody whose date of birth falls on the current date. So that's anybody whose month of date of birth is equal to the month of the current date and whose day of date of birth is equal to the day of the current date. So nice and simple, we can change the number 6 here to refer to the month function and the date function inside there, making sure I've closed the correct number of round brackets, one for the date function and one for the month function. And then similarly, we can change the in operator here and say day a.dob equals day, and then change our list of 1, 2 and 7 to the date function as well. So providing the day and the month are the same as the current day and the month, we'll return a result. It's probably not much point having the order by clause in there anymore. Let's just get rid of that for the time being, as well as the ampersand and the extra continuation character there. So we can head back to the menu sheet and run that query again, and we'll find the one single person whose date of birth is the same as the current date. Another fairly common thing to do with date criteria is to find all the things which happened within a certain period of time of the current date. So all the events that happened in the last week, or all the things that are about to happen in the upcoming month, for example. Now the data in this movies workbook is a little out of date. The last film released in this list was in 2016. So our date range is going to be fairly wide, but let's say we wanted to find a list of all of the films released in the last 5 years. There won't be that many of them, but we can get this to work still. So I'm just going to change my query back to the film table this time. So I'm going to comment out the actor example and uncomment the film example, just to demonstrate how to calculate a date that was a number of years ago or a number of days in the future or whatever. I'm going to add an extra column that calculates what the date was 5 years ago from today's date. So to do that, I'm just going to tidy up. I'm going to get rid of a couple of these extra columns first of all. In fact, most of these columns. Let's strip it all the way back to the film's release date. Okay, then we can easily add an extra new column. This one's going to begin with a comma and a function called DateAdd. Now the DateAdd function requires you to specify an interval of time for the first parameter, and the intervals are the same as those for the DatePart function. So if you have the DatePart documentation available, you can have a quick look at the intervals available on there. I want to add or subtract a number of years, and to make sure I'm adding or subtracting years, I need to enter 4 y's in a set of single quotes. Now the DateAdd function is a slightly misleading name because you can both add and subtract units of time to and from a date. So I'm going to subtract 5 years, and the date from which I want to subtract 5 years is going to be today's date. So I want to enter the date function, open and close the round brackets, and then close the extra set of round brackets. I'll give that an alias as, let's call it 5 years ago. And then I can concatenate a continuation character. So just to demonstrate how that works, let's head back to the menu sheet. I'm going to tidy things up by deleting everything but the menu sheet first. And then when I run the query, I'll get the date 5 years ago from today's date. Now that I've done that, I can use that value in my criteria. So I can head back to the Visual Basic Editor, and after my from clause, I can concatenate a continuation character, followed by the where clause on the next line, and then another continuation character, and then my criteria will be where the f.release date is greater than or equal to, and then I'm going to copy and paste that same expression. As you'll know if you've watched previous parts of the series, you can't reference a column alias in the where clause, you have to replicate the expression. So having done that, I can close the double quotes there, and then if I head back to the menu sheet and run the query again, that's all the films released since the 5th of June 2016 in this database. Of course, as the name suggests, you can also add units of time using the DateAdd function. Just to give you one simple example of this, let's work out the date on which the film's copyright needs to be renewed. And I'm going to assume for that to work that the copyright renewal date is 75 years from the film's release date. Or at least that's according to Wikipedia. At one point in time, the maximum copyright term was 75 years. So let's have a quick look at how we could do that. I'm going to head back to the Visual Basic Editor, and I'm just going to take away my where clause from this query entirely. And I'm just going to reuse my existing DateAdd function. Rather than subtracting 5, I'm going to add 75 years, but not to the current date. I'm going to add that to the film's release date, so f.releaseDate. I'll then change the alias to say copyright. I'll spell that correctly, copyright renewal date. And then as well as doing that, I'd like to work out which date the film falls into the public domain. So again, according to Wikipedia, after 75 years, their work enters the public domain on the 1st of January in the subsequent year. So we can do this in a variety of ways. We could use the DateAdd function to do this, but it might make a little more sense. It might be a little easier to use the year function and then simply add 76 to the year function to construct the rest of the date. So on the next line, let's open up some more double quotes, type in a comma, and let's calculate the year of the film's release date. We know that that just returns a simple number. And if it's a simple number, we can add other numbers to it. So let's say plus 76. So that will give us the same date in 76 years' time. But I don't just want to get the year. I want to get the date that is the 1st of January in that year. So I'd like to construct a date. And again, we've seen a function we can use to do that. I'm going to use the DateSerial function. So I've specified the year. The month will just be the number 1 for January, and the day will be the number 1 for the 1st. And I'll give this an alias as, what should we call this? Enters public domain. And then we can close the double quotes, concatenate a continuation character. So just putting a few of the techniques we've already seen together to do useful, interesting things. If we head back to the menu sheet and run that query again, there we go, we can find out when we'll be able to watch Jurassic Park for free when it enters the public domain. The final type of calculation we're going to cover to do with dates is to work out the difference between two dates. So to do that, let's first of all comment out the film query again, and then we'll head back to the actor query. We'll build up to calculating the actor's age. I'm just going to tidy things up again a little bit by removing the where clause and the extra continuation character. And then let's get rid of a few of these extra columns here as well. So I want to go back to just the first name, family name and date of birth. And then we're going to create a new calculation involving the DateDiff function. So I'm going to say DateDiff and then open up some round brackets. Now the first thing we do with DateDiff is specify what unit or interval of time we're interested in calculating the difference in. And again, the intervals are the same as those for DatePart and for DateAdd. There's again a separate help page which lists all these intervals out, so the DateDiff function, and you can see all the different intervals in the settings section here. To begin with, I just want to calculate the difference in days between the actor's date of birth and today's date. So let's say for our DateDiff function, we'll go with the letter D in some single quotes. We'll go with a.dob and then the date function. And I'm going to give this an alias. I'll call it as difference in days. And I'll close the double quotes and concatenate a continuation character. And then I'm going to copy and paste that line, and in this same query, let's also calculate the difference in years. So I want 4 Ys for the difference in years, and call the column difference in years. Okay, so having done that, we can head back to the menu sheet. Let's tidy up again a little bit first and then run the query again, and we get these two new columns giving you the difference in days. It's a horrifying number if you find anybody born anywhere near your date of birth and you see the difference in days. It's a horrifying number. The difference in years is slightly more acceptable, I think. Now, I was very deliberate in calling this final column difference in years rather than age in years. And that's because the DateDiff function doesn't calculate age. It calculates the difference between two dates, hence its name, in the unit of time you've specified. So we specified the difference in years between today's date and the actor's date of birth. So you can see that for Tom Cruise, his birthday in this year will be on the 3rd of July, and on that date he will become 59 years old. But he definitely is not 59 just yet, it's only the 5th of June. Likewise, Sam Neill will become 74 on the 14th of September, whereas Laura Dern, whose birthday was in February, is now 54. But the DateDiff function doesn't care about that. We've asked for the difference in years, so that's exactly what DateDiff has provided to us. It is essentially the same basic calculation as though we had done something like this. If we add a new column and simply take the year of the current date and subtract from that the year of the actor's DOB, then this basically gives us the exact same result. So I'll call that as a difference in years 2. Let's just copy and paste that to save a bit of time. And if we run that query from the menu sheet, we'll see that second column gives us exactly the same result. So what if we did want to calculate the actor's age in years, rather than just the difference in years between two dates? There are lots of different techniques you can use to do this. With a quick Google search, you'll find lots and lots of options. I'm going to use a technique that involves a few of the things we've covered in this video so far as a bit of a recap and to show you how to put things together. So the first step is to calculate the actor's birthday in this year. And to do that, I'm going to use a combination of the DateSerial function, the year, month and day functions. So let's head back into the Visual Basic Editor. And I'm going to add a new column, let's say with a comma. I'm going to say DateSerial, open some round brackets, and I'm first of all going to calculate the year of the current date. So that's the first value, the first argument for the DateSerial function. Then I want to calculate the month of the actor's date of birth. And then I want to calculate the day of the actor's date of birth. So in fact, let's just quickly copy and paste and change the month function to say day. I'll need to close an extra set of round brackets and then give this an alias as birthday this year or something like that. Birthday this year. I can then close the double quotes and concatenate a continuation character. And then if I head back to the menu sheet and I run that query again, I'll see what date the actor will become this age. The next step is to work out whether or not the birthday is still in the future. And to do that, we can write a simple logical test which states that the birthday this year is greater than the current date. So let's do that by heading back to the Visual Basic Editor, and then we can add another new column to the end of our select list. And I'm going to say birthday this year, so I might as well just copy and paste that alias and check if that is greater than the current date. So I can open and close some round brackets, give it an alias, and then call it something like birthday in the future, or birthday is in the future, and then concatenate the continuation character. Okay, so when you write a logical test, we've seen this in this style of thing in if functions and switch functions, I should say, in previous videos. Normally you put this inside another function to produce some kind of sensible result. If you write just the logical test portion, you return effectively either true or false. But the values true and false, if I head back to the menu sheet, are shown in Excel as value 0 when it's false, and the value -1 when it's true. And that's a particularly helpful value to return, because if the birthday is still in the future, then the value reported by the DateDiff function is one too many. So if we add the result of this column to the result of this column, then anyone whose birthday is still in the future will be 1 year less old than the DateDiff function reports. Let's bear with it. If we switch back to the Visual Basic Editor, let's add one more column that puts those two previous ones together. We can open some more double quotes and a comma. And all I want to do is refer to the difference in years column. Let's copy and paste that and add to that whether or not the birthday is in the future. So if it is, it will add -1. Otherwise, it will add 0. So let's call that one age and then concatenate the continuation character to the end. Okay, so if I head back to the menu sheet and I run that query again, we'll see that this time our actors are being reported as the correct age based on whether or not their birthday has passed. The slightly messy thing about the technique I've just used is in how many extra helper columns we've created to get to the final result. Of course, in the final output, you probably just want to jump straight to the age result. So we can put all that together into a single columns definition, although it's a little messy to look at in the code. The final result in the worksheet will be neater. So let's head back to the Visual Basic Editor and let's add a new columns definition with a comma. And then I'm just going to copy and paste these different parts rather than write them all out. So the starting portion is to work out the difference in years using the DateDiff function. So let's copy and paste that first of all. Then I want to add to that the result of comparing the birthday in this year with today's date. So I'm going to add to that. And then I think I'm going to use a continuation character here, otherwise I'm going to run out of space at the end of this line. So I'm going to concatenate that onto the next line and indent that with another tab space and open up some more double quotes. So I want to check if the result of constructing the birthday in this year, so I'll copy and paste my DateSerial function, is greater than the date function. And I'm going to wrap that little section of code in some round brackets as well. So that entire logical test returns either the number -1 or 0. Then at the end of that, I can simply add my alias. Let's call this one as age. And then I'm going to get rid of the other columns. So let's get rid of the age, birthday in the future, birthday this year, difference in years. In fact, I'll keep the original difference in years just to show that this is now calculating the correct result. Okay, so having done all that, let's head back to the menu sheet and run that query again. And we'll see that for anyone whose birthday has not yet happened this year, their age is now being reported accurately. So there we go, there's a range of different functions you can use to perform calculations with dates. In the next part of the series, we'll do something similar with functions designed for working with text. So I hope you're looking forward to that one. Thanks very much for watching as always. See you next time.